Okay, I've got a dynamic question here. What I've got, this is my slope that I've drawn, 15 degrees. On that slope, what I have is a lifeboat, apparently. Let me just draw that as a block. Sliding down, I know certain things about this. I know that it starts at rest, so velocity 0 here. I know it gets to 12.6 here. I know that the distance is 50. So actually, what I do know, let me just give an equation of motion here. I know that v squared, final velocity squared, equals initial velocity squared plus 2 times the acceleration times distance s. And if I put that in my calculator, I see that a equals 12.6 squared divided by 2 divided by 50, 2 times 50. I'm going to find that acceleration equals, what's that going to be? 15876, my calculator is saying, meters per second squared. That should come in useful. Now, forces. I have a weight of 800 G. Of course, it's not falling through the ramp, so there must be a reaction force stopping to do that. And of course, I've got a frictional force. Now, if it's moving, friction is maximum, so it's coefficient of friction times reaction force. The reaction force, of course, is always perpendicular to the plane, and the frictional force will be opposite the direction of motion. That's what we've got. Angles, I know my ramp is at 15 degrees, and so I can see that I've got another 15-degree angle just here. Start balancing things up then. If I look across here, I can see, well, there's no movement going through the plane. This tells me that the reaction force going up must equal the component of the weight coming down. So reaction up equals 800 G, and that will be cosine next to, adjacent to that 15. So 800 G and adjacent to cosine 15. There we go. That's my reaction. That also tells me, of course, mu times reaction going up. Coming down the slope, of course, what we've got is we've got an acceleration. And where we've got accelerations, we've got forces. So coming down the slope, what I know is I've got F equals ma. The force coming down the slope, it's the weight that gives me the force down the slope, but not all of the weight, of course, just the cosine this direction, the sine component. So 800 G, that will be sine 15. Going down the slope, minus, of course, the friction which is going up, mu times r. So force equals mass times acceleration, and acceleration I've already worked out to be 1.5876. What I've got to do now is I've got to sort this out. So let's start turning things around. So I've got 800 G sine of 15. Let me subtract this one, minus 800 times 1.5876 equals, let's add the mu r onto this side. Quick turnaround. And so I've got this 800 G sine of 15. You can start just throwing all this in your calculator. 1.5876 equals mu, divide everything by r. Of course, I know r is this here, so I'm going to divide everything by 800 G cosine of 15. It looks a bit complicated, but that is all just numbers into your calculator, and you will see that mu equals 0.100 blah blah blah. So let's round it to 3 significant figures. 0.1 is my coefficient of friction, and we're done.